Hello everyone. Today I'm going to explain general mechanism of electrophilic substitution reactions. These are the characteristic reactions of aromatic hydrocarbons such as benzene, the most common one. Benzene is a planar molecule. Each carbon is sp2 hybridized and the pi electron cloud is lying perpendicular to its plane, which will attract the electrophiles to attack, and hence it undergoes electrophilic substitution reactions. So in the reaction mechanism, the first step involves generation of electrophile. Okay, in the first step, so heterolytic fission will produce an electrophile, which is electron seeker. In step 2, it is going to attack on benzene ring through the electromeric effect. Every carbon is containing one hydrogen, the C6H6. So what happens? This pair of electron is used up to form bond between this electrophile and the benzene ring. So you are going to get an intermediate species which is called sigma complex or a carbocation, right? This is called sigma complex or arenium ion. This is resonance stabilized. Okay, we'll just see. This arenium ion will show resonance effect. Now, since this carbons, the top carbon's electron pair is used up, the electron pair which was there between this carbon and this carbon, so that is used up in formation of bond with the electrophile. This carbon will acquire positive charge. And this is, since now this will become electron seeker, so this is forming a conjugative system. This will pull this electron pair towards itself. And in the next resonating structure, the positive charge is acquired by the carbon which is present at meta position. And after that, again now, this carbon, after gaining the electrons, now this carbon no longer will be positively charged. This carbon which has become now positively charged will pull electrons towards itself. Do not forget to complete the structure. And now you will be having a positive charge on this carbon. Actually. So these are the resonating structure. You can also show the resonance hybrid in which this positive charge is spread over these carbons, not the carbon on which the electrophile is attached. That's why we show it by not a complete circle. We do not show the complete circle. We show only this much part. Okay, we do not include this carbon into the circle. So this is the resonance hybrid. Now in the last step, step 3, any base is going to attack and it will pull out the proton from the benzene ring. I can show it like this also. We will take the first structure, this one. This has acquired positive charge. This is hydrogen. So any base will pull pull out the hydrogen as proton, and this electron pair, okay, this shared pair of electrons between this carbon and this hydrogen will be utilized in the formation of a pi bond, and hence completing the octet of every carbon in the benzene ring. So you are going to get your substitution product like this. This is your substituted product. Okay, so here the hydrogen is substituted by the electrophile. That's why it is called electrophilic substitution reactions, which are the characteristic reactions of electron-rich benzene ring. I can take an example also. Nitration. During nitration, in the first step, an electrophile is formed in which the nitration mixture is H2SO4 and HNO3. So in this process, I hope everyone knows the HNO3 structure. So here there is one coordinate bond between this oxygen and this nitrogen, and nitrogen has already acquired positive charge. This is negative. This is having lone pairs. So in the first step, this is the proton acceptor. The nitric acid is the proton acceptor, and H2SO4 is the sulfuric acid is the proton donor. So after accepting the proton, it will turn into protonated nitric acid. Since you know that oxygen dislikes the positive charge, so it will easily be removing one water molecule and one electrophile is generated. This is the first step. So this will be taking up this electron pair towards itself, and it is going to produce nitronium ion, which is the electrophile. Nitronium ion. Now, in the second step, this nitronium ion is going to attack on the benzene ring in the same way as we have seen in the general reaction mechanism. So this is going to get attached at one of the carbon after taking up the shared pair of electrons, right? And then this carbon will acquire positive charge. Okay, this is our sigma complex or the carbocation or arenium ion, which is resonance stabilized. I've already shown you the resonating structures, so I'm not going to repeat here. This is resonance stabilized. In the next step, the base which was produced in the first step, which is HSO4 minus, that is pulling out one proton from the benzene ring, and this shared pair is used again in the formation of pi bond. Hence you are getting the substituted product as nitrobenzene. Other examples are Friedel-Crafts alkylation, Friedel-Crafts acylation, halogenation. All these follow the similar reaction mechanism, which is electrophilic substitution reaction. Thank you, people. I hope you understood. Take care. Bye.